All right, guys, I'm glad you're here. Everybody have this from last time? We didn't quite finish, which is actually perfect that we didn't quite finish this, so we can sort of review. You also need. Totally. You missed last class?
Yeah.
Oh shit, watch that video. So, let me see. Oh good. I get a little more balance to the force here. I like it. Which one's the dark and light side? I'll let you guys decide. Can somebody remind me what T-scores are all about? Why were they invented? Just because somebody got too drunk from Guinness and made some weird shit up, or what?
It's the Z-score stretched out when you don't know the population standard.
Good. So, to me, it always made some sense. If there's something I don't know that I'm trying to throw into a formula, I've got to kind of be penalized for that. I got to cover for that. So the idea is, the smaller my sample gets, the less certain I am about S. And real quick, I think I told you guys this not last time. What is the job of S? This is such weird questions, but just too bad. What is S's job? What is S? Sample standard deviation. What is its job? That's a really weird question, I know, but.
To get us close to the population.
Yeah, it's supposed to kind of approximate the population standard deviation, correct? So if I know the population standard deviation, I am completely allowed to use a z-score, assuming it's normal, right? It's got to be normal for us to do anything. Is everybody with me? You guys all right? All right. So t-scores were invented for when I did not have sigma, when I only had S, which is an approximation. So if I'm trying to get a feel for where something is, and there's something about the situation that I am less sure about, I've got to expand my idea of where something is. Does that make sense? So like, has anybody ever seen, what's the movie? The Fugitive, I think. Harrison Ford, the one-armed man?
Yeah.
No? So there's like a bus taking all these prisoners to another place, and it rolls over, and the prisoners escape, and they're like, okay, our man can probably run this fast, so let's make a search circle this big. You with me? Everybody with me? Even if you never saw the movie, somebody escaped, there's been a certain amount of time, they're like, oh, the average person can run this fast, so we need to make a search prisoner like this big. Are you guys kind of with me? If I am not sure the condition of the person, if they're really athletic or not, to cover my ass, shouldn't I make that bigger?
Yeah.
That search area? Okay, that's all t-scores do. There's a piece of my equation that I'm not sure about, and that's S. I don't know if that's like approximating sigma well. And if my sample size gets smaller, aren't I even less and less certain about that? You guys, does that make sense? The smaller my sample, the less sure I am about the S I get.
Yeah.
Does that make sense? You guys knew coming in that a bigger sample was better. And that's one example of that, right? Okay, I like it. So, whatever this t-score is, it's going to act like a z-score. So just like a z-score, the distribution has to be normal for it to be used. But what a t-score does, like Charlton said, is it just pushes the confidence interval out. And the smaller my sample, the more it tries to push it out. Now mathematically, what does that mean? The t-score number will always be bigger than the z-score would have been. And that accomplishes pushing that interval out a little bit. Is everybody cool with that idea? Okay, so that's all t-scores do. They are z-scores, just a little bigger, adjusted for how big my sample is. So if my sample is large, whatever that means, I love when I'm just randomly bleeding. If my sample is large, what does that mean? Do I need a t-score any more then? If my sample is large, I'm like, okay, my S is pretty damn close to sigma. I'm just going to use a z-score. That's why there are z-scores at the bottom of your t-score chart. Because when the sample is really freaking big, I feel really good about my S being close to sigma. I don't need t-scores help anymore. That's why I will often use the t-score chart to find a z-score. Okay, that pretty much catches us up with T-scores. We did this, bless you. If you missed the last class, that little lecture in a nutshell will not cover it. You're gonna need to watch that video. But we did this last time, right? Anybody else still need this handout? Uh-oh, all right. I always gotta remember to check to make sure I have before I ask. Oh, everybody else good? Okay. Poor little cameras up in the front row, like. So we did this. We didn't finish this last problem. So does all this look familiar? You guys remember doing this? Those of you that were here? Yes? So the only weird thing up here was when we got to this one. What is degrees of freedom for us at this moment? No, I mean, in general. What's the degrees of freedom defined to be? N minus 1. There are situations that we might see in the future, depending on if we have time, where the degrees of freedom might change, but most of the time, degrees of freedom is defined to be N minus 1. So right here, part C, what was the issue with part C? There's no 92 on the freaking chart, Jeff. What the shit, Jeff? You gave us this chart. So in those situations, you just go, does this make sense? The whole idea of a T-score is to sort of penalize us for not knowing something. So that's another layer of not knowing something. So I just go to 90, which gives me a bigger T-score to cover my ass for still not knowing even more. Yeah.
So say N minus 1 was 95, would you go to 90 or to 100?
Still 90. Technically, if you get 99, you should still go to 90, but if you go to 100, I'm not gonna cry. Especially because if you look at your T-score chart, do you see how little things change? The bigger, and that's why they step by 1 and then 5 and then 10 and then 100 and whatever, yeah. All right, let me stop there for a minute. Comparatively, reading the T-score chart is pretty straightforward. So let me ask you a couple of questions. If I wanted a 98% confidence interval, what is alpha?
0.02.
0.02, kick ass. Can you find a z-score I would use on your T-score chart? If I want a 98% confidence interval, you just told me alpha is 0.02.
2.326?
Yes. You guys see 2.326?
Yeah.
So let me show you. If I want 98% confidence, that means alpha is 0.02. Confidence intervals always make two tails. Now, if there's 2% in two tails, what percent is in one tail? It's 1%. Still the same column, right? And if I want a z-score, I just don't stop. You with me? If I stop, what kind of thing do I get? T-score. If I don't stop, I get a z-score. So there ain't no party like a z-score party. That's a dumb joke and I don't care. Alright, so one thing we're going to learn today is why the hell does this chart have a one-tail and a two-tail row if all the confidence intervals are two? Well, one reason is we don't only use this for confidence intervals. We use it for other reasons. So, one little thing I want to do, actually there's two things. One is we didn't do this last problem, so if I could get everybody to please, if you need a calculator, come up and get it. Because I want you to calculate some stuff. Basically, I want you to do what this says to do. What's he doing? Oh my goodness. Never saw that episode. Yeah. Yeah. Maybe. Oh yeah. Do you need one of these?
Yeah.
Okay. All right. So everybody's got T-score chart. Everybody's got this dude here, right? All right. Now, everybody, part A. I'll do it at the same time. Whoever's phone this is, it's telling me something. Oh, it's telling you to be here. How do I stop? Stop.
You got anything? You know how to do it?
Is there a fast way to clear all the lists?
Yeah, if you go to stat, one option's clear list,
Oh, okay, I see.
and then you could put a comma delineated list of lists. So like you could put L1, comma, L2, so that's one reason why there's a comma on the calculator. Calculator, let's see. Okay. How do I get the sample mean and the standard deviation, what do I do?
One more stats.
One of our stats, and I kinda told you anyway. So stat, calc, one of our stats. Make sure your freaky list is empty, cause we don't have a frequency list, right? Everybody with me?
Yeah.
I got that. What's the sample mean?
15.7.
No. Let me try it. What's the sample mean?
78.257.
286.
Good, 78.286, I like it, that'll work. And what's the standard deviation that we're gonna use? Now come at me.
15.724.
Why don't I use 14.557?
That's the population.
That's sigma. Why don't I use it? Then I can use z-scores, right? Why don't I use sigma?
You're using a sample.
Because it's a sample, I love it. So remember, the calculator's dumb. It can do a lot of shit, but it's dumb as hell. So it just spits both standard deviations. I know tonight my calculator's gonna like strangle me in my sleep at all. It gives us both, because it's like, I don't know what numbers you put in me. I don't know what they mean. Here you go, human, you pick. Are you guys kind of with me? And it's really important now, because if I don't know sigma, I must use z. And a lot of students just go, well, I know sigma, it's right there, Jeff. You can't use that shit, because it was a sample you put in. Does that make sense? All right, so be really careful about that. Okay, so let's write that stuff down. You need a writing utensil to do that, Jeff, I know. What are you? Sure. Blood red, let's see. So my sample mean is 78.286, and the standard deviation is 15.724. All right, so I kind of prepped you for this. What's the only thing we don't know for this formula at the moment?
T.
We don't know T, we know everything else, right? So take a minute, figure out the correct T-score. And I kind of gave away the game here. I should have asked you what to use, but of course I'm using T because I only know S. Now what else? What else must be true? In order to do something, what has to be true? My distribution has to be normal. Is it sample size big enough? No, but I do say it's already normal to begin with. So whenever I take samples from a normal, that they're going to automatically become normal if I plotted all the sample means. So I don't need n greater than 30 because it already told me it started off normal. I like it. So keep going. Figure out what T is. Plug that in. I'll catch up to you. So I filled out pretty well. Let's see. 6, 8, 14, 22, 24, 25. So I'm only missing 11. Only. Sure, Jeff.
I have 22.
What's alpha? How confident do we want to be? There, I'm sorry. I was looking at what's an alpha? Okay, I'm with you. Okay. Yep. And now you gotta go to degrees of freedom so you know where to stop. No, what's degrees of freedom? There's 7 in the sample, right? 6. make sure everybody's on the right track, for 98%, which column am I looking at?
0.02.
First, second, third, fourth, fifth?
Second.
Second. What's the degrees of freedom?
6.
There we go, that's 3.143, I believe, right? Am I looking at that right? Yeah. So, if you stop, you get a T-score. If you don't stop, you go all the way to the bottom, it's a Z-score. You just gotta go in knowing which one you want. So let's see, it's gonna look like. One easy mistake I see students make is they'll put a 6 here, because your brain is stuck on degrees of freedom, but it's gotta be the full N, dude, that goes there, right? So, fundamentally, the only difference between this and section 8.1 is we just look at a different chart, right? To get that. Everything else is the same.
So for the next test, are we gonna need both the Z-score chart and the T-score chart?
Oh, yeah. I mean, yes. Became the
And then just to confirm,
Kool-Aid
is it
man there for a
on the
second.
13th
Oh,
or on the
yeah.
15th?
What?
Just ask.
I'm sorry, do it again.
Is it on the 13th or 15th?
I can't remember. What's the homework sheet say?
Well, homework says 13th, but that's on Monday before you go on break, so.
Okay. That's probably what I meant. I can't remember now. Whatever it says on there, that's right. That's my other brain. I make that so I don't have to keep it here. You know what I mean? So, yeah. That's why we're gonna have, in case you didn't notice, we're gonna have a quiz on Monday. And now I understand, now I remember why past Jeff did this. One reason, I was gonna have it this Wednesday and I forgot to tell my other class, so I just have to push it to Monday, cause they don't like not telling a class, at least one class, but anyway. But then it gives me time to grade it for Wednesday, so then our test is on Monday. So then you got time to make corrections. Alright, so what do you guys do first when you go to do this? What's the first thing we should do? Yeah, do the error first, right? You see this? Yes.
It's plus or minus 18.67.
18 point stuff?
Yeah, 18.67.
Alright, I'll trust you. 6, 7, 9. Does that sound good, everybody? Yeah. Okay. So then it goes from, what is that, 59.607 up to 96.965?
Yeah.
Okay. Now, real quick. What the hell does that mean? You gotta write the conclusion. If you haven't written the conclusion yet, do it, and then I'll catch up to you. See if you can write the conclusion. And then we'll talk about if this interval's even worth anything. And you're all like, Jeff, none of this stuff. Say again?
What are we supposed to say when
There's not really a unit for grades, truly. It's not really a percentage, so you're good. This is one time we don't need to put units. So we are, alright, farmers, 98% confident that the interval.
The true mean grade?
No, at the interval. 59.6 blah 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 to 96.965 blah blah contains what? Now come in.
The true mean.
Population,
true-
mean grade.
Or the population, I love it, so I just say true, I don't know. The true mean grade, there, this is detailed as they were. Okay. When I say they, I mean me.
Can you say we are 98% confident the true mean grade is between 96? No.
Real quick, so the true mean grade exists. It is already somewhere. Our interval is created, and we're such and so confident that the interval we made catches that mean. If you make it go the other way, it seems as if the means comes into existence after we create our interval, which is not true. So it sounds like semantics, but it's actually kind of central to the idea of intervals. Does anyone remember, I'm pretty sure we talked about this, what the hell does it mean to be 98% confident? What does that actually mean?
You have 98% of the, or 98% sure.
Okay, I don't mean break out the thesaurus. I mean, like, what does it mean to say there's a 50% chance I'll flip a head when I flip a normal coin? What does that actually mean? If I flip it once, it doesn't mean shit, right? What's the 50% mean if I flip it once? It's gonna be heads or tails. So what's 50% mean? It's gonna be 100% one of those things, are you with me? So what does 50% probability of a head mean? What does it actually take on meaning? I have to do it a lot. So if I flip the coin 1,000 times, how many do I expect to come up heads? 500, 50%. It should be close to that, and that's of course we start talking about I expect 500, and then we say should be close to that, and then we can develop the idea of standard deviation, blah blah blah, right? Okay, baby. So what this means, and what we're going to see actually, we're going to see it happen today. Is my hope. It happened beautifully in my other class. Not that they did anything special. It just happened. It's a random chance. We'll see if it happens today. You're all like, I have no idea what the hell this guy's talking about. You'll see in a bit. This means if a bunch of different people took a bunch of different samples from that same population and they made a 90%, 98% of them would actually catch the real mean, 2% of them wouldn't. That's what that means. And that's why we're 98% confident ours does, because 98% of all of them do. So of course we're 98% confident that mine does. Does that make, no? All right, some of you guys are still, they always look at me like, maybe you'll start making sense now. Okay. So, turn this sheet over. And yeah, some of you guys are already at. And you'll see the Great Wall of data that can be seen from space. Okay. And just to let you know, this is true data. I think I collected this back in 2016. So forgive me for not updating this, I'm sorry. But this is true data as far as that's concerned. Here's what's gonna happen. I'm gonna do this with you. I need each person in here, I need you to get a truly random sample from there. Does everybody understand? You can work together to help each other out, but you should all have different data points. Are you with me? So not everybody should pick the first 2 rows or something. Like I would just look away and put my pen down and then take that data point and then take that data point. You with me? Sort of like if you had a dart, you could just put it up on the wall and throw a dart at it. Just put a pen on it or a pencil. Are you guys understanding what I'm saying? I want you to try to make this as random as possible. Then a certain thing has a better chance of happening. Are you all with me? So the very first thing you need to do with this is to find a truly random sample of 20 grades. So one way, this is how I'm going to do it. I'll start doing this. I'll do it this way. Right? Do you understand? That's probably the most straight. So I just take my pen, I'm now looking at it, and then I go, oh, I'll take that one. Do you guys understand? That is one way to do it. You could be more creative if you want to. But please, dear God, don't everybody take the first couple rows and say, I did cluster. No, come on. Try to make it different, right? If you don't believe me, I'm going to do this shit. Here we go. something different from earlier. Oh man, I'm not counting, I've told you. That's enough. Okay. Now, once you got your sample, you could do part B, just like we did a minute ago. Find the sample mean and the sample standard deviation, right? Same way we did a minute ago. Okay, so, alright. Let me know if you need any help. Everybody should get the exact same T-score, because we're all taking the same sample size. I'm sorry.